Alright, Casey, so that's the equation that you sent through to me. And the main question that I think that you had was, how come we ended up with, and the next step of this equation, there was a 36 that appeared and some other numbers that had been multiplied through. I think that the main point to understand here is that the biggest problems presented to us are these guys, the denominators. So those guys, what we have to do to eliminate them is do a multiplication. So I could just go and multiply by 4 and by 6 and by 3 and then multiply every single term by each of those numbers. But what we'll find is our numbers get really big and we've got to multiply everything a few different times. So what I stop and do instead is say, what is my lowest common denominator? What's my lowest common denominator between all of the denominators? So if there are only 2, I just have to pick 2 numbers. But in this case, I've got to pick the lowest common denominator of 3 numbers and avoid just multiplying all the numbers, the denominators, because then that same problem will exist where we have those really big numbers that we have to multiply through. But what I see, the smallest number that has both 4, 6, and 3 as a factor is 12. Okay, so I have options, and the first option is to go and make all the denominators 12. So I'm going to have 12 plus something else over 12 equals something over 12 minus something over 12. Okay, so I have to multiply each of these terms by whatever gets me to a denominator of 12. So that, by the way, is 3x over 1, which is where we end up with 36x. So it's 3x times 12 gives me 36x. Then I end up with, I've had to multiply this by 3. So that's 3 outside of 4 minus 2x. That is a minus. Is equal to, I've doubled that one, 2 outside of 5x plus 3 minus 8 over 12. So now the thing I can notice is that because all of my denominators are the same, I can just eliminate them all. It's like I've multiplied each of those terms by 12, which will give me 36x plus 12 minus 6x equals equals 10x plus 6 minus 8. Now, again, those denominators of 12 could all still be there, but if everything's being divided by 12, I can just proceed without them. So I end up with 30x plus 12. I'm not sure if this was part of the question you were having problems with as well, but I'll run through it anyway. Equals 10x minus 2. I'll start by getting my constants over to the right. So I'll end up with 30x equals 10x minus 14. And then I'll take away 10x. I'll end up with what? 20x equals minus 14. I'll divide by 20, and that gives me minus 7 over 10 as our nice answer. So the other option here is to straight away, rather than rewriting this step with all the denominators, is to just proceed almost to the line, well, not the line above, but just rewrite all the numerators with their multiplication. So really what I've had to have done here is I've had to multiply this one by 12, this one by 3, this one by 2, and this one by 4. So it's that old idea of whatever I do to the denominator, I must do equally to the numerator so that I don't change anything's value. And I have to do it to each and every single term. So that's why going down that avenue of saying, well, I'm going to multiply by 4 and then by 6 and then by 3 is probably not a good one, because you'll probably forget to multiply something. So I think either rewriting them with all the same denominator or going ahead and just rewriting this straight away without having the denominators all is your best approach. Please don't get this confused with an algebraic fraction. If we have a fraction that's not equal to another set of terms, so not an equation that we're trying to solve, so something like this, x on 5 plus x on 3, well, you can't just go and eliminate the denominators there, because they're not being eliminated with anything on the other side of the equation. So that you would just have to go and do this process as well, but you would need to leave the denominators as they are. We're not trying to eliminate them, we're just trying to put them together. I hope this helps. Don't stress either way, and you'll be fine.